We will be doing question 29.47. A room with 3-meter high ceiling has a metal plate on the floor with V equals 0 volts and a separate metal plate on the ceiling. A 1-gram glass ball charged 4.9 nanocoulombs is shot straight up at 5 meters per second. How high does the ball go if the ceiling voltage is A, 3.0 times 10 to the 6 volts, and B, negative 3.0 times 10 to the 6 volts? So for part A, we're going to write down what we know so far. We're going to write down that we have a height of 3, mass of 1 gram, charge of 4.9 times 10 to the 9th coulombs. The ceiling of the charge, well, plus and minus, since for part A is plus, for part B is minus. Voltage of the ground. We know the difference between, or for part A specifically, the voltage difference between the ceiling and the ground is 3.0 times 10 to the 6 volts. So we're just going to draw out the situation here. We've got the ceiling, the ground, mass, and the force of the charge and the force of gravity. But we'll get more detailed in the next slide. So the direction of the field lines start on the positive plate and end on the negative plate. You can see here that they go down. Since the ceiling is positive, the net electric force is downward. And so we have the equation right here that we can use to find the initial speed. And once you plug everything in, you get 5 meters per second. So when the ball is shot up, straight up, at the max height, V max equals 0. So using that, we can use this equation, and we can plug in all the numbers, do the math, and we get that the final height was 0.85 meters. So part B is very similar to part A. In fact, just the charge on the ceiling and the charge of the ground are just flipped. And so we can say that the potential energy at the ceiling is negative 3 volts. So the potential difference is once again 3.0 times 10 to the 6 volts. So we can use the equation again to find the net force. And so we have mass, acceleration, all the goodies. And we plug them in, and you get your value that you want. And so as you can see here, that we once again have we have the positive charges on the bottom, negative charges on the top, and so the electric field are going upward. So with the formula, once again, b squared minus c squared equals 2as, we can write it again as in this form, which might make it a little bit easier. We can plug in all the numbers that we've got, the speed, the voltage, coulombs, distance, and mass, and we can do the calculations. We'll get an answer of 2.55 meters.